The substitution property, let x plus r equal a. In any expression, a can replace x plus r. So in this example, we want to factor the expression x plus 3 squared minus 2 times x plus 3. This is a bit confusing, so if we use this substitution property to make it look a little simpler, it'll help us. There are two terms, and the factor x plus 3 appears in both. So we have x plus 3 here and x plus 3 here. So if we just replace x plus 3 with the letter a and then rewrite it, it becomes a squared minus 2a, which is a lot easier to look at than this longer expression. So we have that a is the greatest common factor here. See, a is the greatest common factor for this entire expression. So we can take a out. Then we are left with a minus 2 in here, which you can solve just using the methods we've been doing. And then you can see here that once you have this set up with the greatest common factor, with whatever's left over, we can just plug x plus 3 back into the equation. So we plugged x plus 3 back into this side, and we plugged it into this side, and we can see that here's our original expression here from up here, and that equals a factored form of x plus 3, x plus 1. Here's another example. Factor the expression y plus 1 squared minus 4 times y plus 1. So we can see that y plus 1 appears in both of the terms, and we can replace that with the letter a. So that leaves us with a squared minus 4a. The greatest common factor here is a, because a is in both. 4 is here, but the coefficient over here is 1, and this one's 4. Therefore, the greatest common factor for the coefficient is 1, and then we have a squared and a. You're limited by the smallest degree, so a is our greatest common factor for the a's. So our greatest common factor is just a. So we have a on the outside. Now we don't need to figure out what we're left with here. So we have a squared minus 4a. We can divide each term by our greatest common factor of a, and we are left with a times a minus 4. And then all we have to do is plug in y plus 1 back into this to solve. So we have y plus 1 times y plus 1 minus 4 equals y plus 1 times y plus 1 minus 4 gives us negative 3. So, and if we plug y plus 1 back into this original equation, we'll just get what we originally had, which is y plus 1 squared minus 4 times y plus 1. And so here is the factored form. Y plus 1 times y minus 3. Factor the expression. Alright, so to simplify this, let's replace z squared plus 5 with a, capital A. So that leaves us with lowercase a times capital A minus capital A. What is our greatest common factor here in this expression? Well, we have a lowercase a in this term, but we don't have one over here, so it can't be in the final greatest common factor. But we do have one capital A in each term, therefore our greatest common factor is a. When we take a out of here, what are we left with? Well, we have our original expression that we can rewrite, and then all we have to do is divide each term by our new greatest common factor, and we are left with a times, well, these cancel, leaving us a lowercase a. Those cancel, leaving us 1. And then when we're at this stage, all we do is plug this in for a. So we have z squared plus 5 times a minus 1. And that is our factored form of this expression. All right, here we have an x plus y in each side, so let's replace those with capital A's. So we have 3x times a capital A plus 4y times capital A. What's the greatest common factor between these two terms? Well, for coefficients, we have 3 and 4. The greatest common factor between 3 and 4 is 1, so we don't have to include that at all. We have an x here, but there's no x over here. Therefore, we don't have x in our greatest common factor. However, we do have a and an a. So a is our greatest common factor. We take a out of our equation, and then we have to figure out what's left on the right side. So we put in our original, we put that in here, 3x capital A plus 4y capital A. Divide each term by our greatest common factor, a, and we are left with a times, so 3x is left because these a's cancel, and these a's also cancel, leaving us with 4y. And our final step is just to replace a with x plus y. So we have x plus y times 3x plus 4y. And that is our factored form of this equation. All right, finally we have this one. So we have x minus y here, and we have an x plus y here. Therefore, we can't replace this with anything. So these aren't the same, like how in these ones are all of the same. So that's it. That is our factored form of that equation. So we have z squared plus 5 times a minus 1, x plus y times 3x plus 4y, and then this cannot be factored because these aren't the same. So these aren't a greatest common factor of these two terms.